Hi, welcome to IncluIT Video TechTalk. My name is Gaston.Galera. I am testing for an automotive project in IncluIT. I have been working in testing for more than 11 years, and now today I will talk about how to implement a machine learning technique in a testing task, like for example a regression test suite, how to prioritize a regression test suite. I decided to prepare this presentation because I listened some time ago about machine learning. I read papers about machine learning, research about it, but I found a lot of theoretical information, but nothing how to apply machine learning in a day-to-day task or testing task, or how can improve our task. So I decided to do a researching and apply machine learning in a testing task, like in this example, to prioritize the regression test suite. Why a regression test suite? Because it's a complex task that if you have a few test cases in your suite, the task is not so complex. But in our cases that we have more than 7,000 test cases, and you have to prioritize all of them, maybe it's a task that can take maybe, I don't know, a few hours of one person, of a group of person, but it's not a simple task or easy task to solve. So can apply a machine learning technique, you have to have two things. One task that require processing, like in this case, how to identify which test case is more priority than other. And the second requirement is a big amount of input data or historical data. So in this case, for this case, I have that. So I apply a machine learning technique, and I want to share in this presentation. But how works machine learning, and how can help us in this procedure, on this task, to create an algorithm able to prioritize the test cases as an expert or a group of experts can do it. So basically, the machine learning start with the input data. In our cases are the test cases. Then there is a works that we can try to identify the features that defines or help to identify which test case is more priority than the other. For example, if the test case found a bug, if the test case was executed some time ago, maybe it's high priority, or the functional area that is testing is high important. So based on these features, we teach the algorithm to learn about how the test case or the value that for each feature has the test case, so can identify the priority between them. Then, after the machine learning process it generates an output, and in our case will be the priority for each test cases. Although machine learning and testing are really different things, they can mix very well. For example, I found examples in the web that we can use machine learning to predict if a defect could be reopened in the future. We can identify, based on the code lines, if the way that the code was written, it will we can find issues for that part of code. Also, based on the requirement, if the way that the requirement was written, if we can have issues or defects in the future. So these are some examples that how we can mix machine learning with testing. I will start with the theoretical part a little bit, and then I will show how I overcome the challenge and how to use this algorithm. Machine learning, we can identify three different types of machine learning. One is the supervised learning, and this is the machine learning that when you put the information in the machine and you see and you teach to the machine which is the expected output, or which is the output for that. Another type is the non-supervised learning, where you put information in the machine learning to the algorithm and you wait to see what the algorithm output is, and you don't see which the classification or nothing special. So the algorithm identifies something and show us output. And the third type is for reinforcement learning. That is a mix of previous both, where you put information in the input data in the algorithm show an output, and you have to tell to the algorithm if the output is correct or not. So this is the three types. And for this example, for the prioritization of test cases, I will use an supervised learning type, and it's called SVM-Rank, and it's an algorithm that is free and you can obtain from the website, and it's easy way to use, just a command line, and then I will show how to use it. SVM-Rank work showing the value for each feature that I mentioned. So depends on the weight of each feature and how important this feature is for the test case. In this case, the algorithm will rank up or down this test case. So it's how this algorithm works and why is applied for this example. I mentioned that we have two requirements to use machine learning, and one is a big amount of data, and the other is apply for a task that requires processing. For the amount of data, it's really important that we can separate in two suites, on two groups, one for the training the algorithm and the other for evaluate the algorithm and check if we have to fix something or the result is good. So the training data is recommended that has to be more or less 700% of the total of the data, and the 30% of the other data you have to maintain and don't touch it and don't train the algorithm with this information. This is the data that I use to train my algorithm. More than 27,000 of test case executions, and the feature that I found were pass-fail ratio, back-fail ratio, number of bugs found, latest failures, when was the execution, number of execution, the functional area for each test case, and these are examples, and you can identify or have more feature if you think that is important. This is the input data format for the SVM algorithm, and each line is each input data. So in my case, each line is one test case execution information. So one line represents each test case execution with each value for each feature. In the line we have the target that represents the priority that I set for each test case. Because I have to teach the algorithm with the and say if this test case is more important than another test case, putting a weight in each feature. So if the test case was executed long time ago, this feature for this test case will be more important than for one test case that was executed sooner. Then after we have the target or the priority, the highest value is more priority. We have the QID, that the QID represent if in some case we have a group of different input data lines but represent the same input data. It's not this case because in my case I use one line for each test case, but if you have one input data that three lines that represent one input data, so you can group them by QID. And then we have the features that we identify that I mentioned previously, like for example pass-fail ratio, and the weight or the value for this feature for this test case. Then the another feature, another value, and at the end we have we can add a comment. In my case, I add the the name of the test case to identify the line for which test case is. One thing to mention here is if I put the value 0 to a feature, this it doesn't mean that is the lowest value. That means that this feature will be removed from the algorithm to compare with the other test cases. So take care and put value 0 value to the feature that you don't want to use for this test case, for example. I will give an example to better understand. If I have two test cases with the same feature, in the first test case I found a bug, and the second test case I didn't find it. So the first for the first test case, the feature will have more value than the other. So I had to put or mark that difference to the algorithm understand and could compare. If I remove the value from one test case because I say or I think, okay, the second test case didn't found test case, so I remove the value, the algorithm will not compare them, so the ranking the rank about both cases will not be the correct one. Don't apply 0 as the value because it will not be included in the comparison and we can get incorrect ranks. You can use positive or negative values instead. Okay, now I'm showing how I use all the information that I can get from the test management tool and how I convert that information in a value for the features. As you can see, I have information like a functional area, number of execution, number of pass, number of fail for each test cases. But now I have to convert the functional area in a value. So I use a function to put the functional area which has the highest number of issues with that convert in highest value, and the area where we don't have a lot of issue in lowest value. So now I have each functional area with or one value for represent each one. Then I have, for example, the number of execution. So I have to convert for example, if the test case has a lot of execution but always pass, the value for that is lower than not more or not many execution, but when found some issues. So the important things or the important value we have to put a highest value for the feature. For example, the one test case that has or was executed long time ago will have more value than a test case that was executed 3 days ago. Then, so this is how we pass from step 1 to step 2. And then when we have the step 2 completely, we are ready to move that to the format that is required to the SVM-Rank algorithm. It's like the step 3. When we push that information in the SVM-Rank algorithm, we get, after maybe 1 hour, we get a model. This model represents the weight for each feature in the algorithm. So now we are ready, or our algorithm is ready, is trained and is prepared to insert or to be tested with the evaluation set, data set. Once we introduce the evaluation data set in the algorithm, we can get the output, in this case the prediction, and if we put in order the test cases based on the prediction value, finally we can get the test cases prioritized. So don't be afraid to use machine learning or innovation for the common testing tasks, and please don't be afraid to share your ideas also. Thank you, and feel free to email me if you have any question, and see you in the next Tech Talk.